Okay, for 34, they have a table of drop height versus rebound height. So A says what's the rebound ratio. Now, we know it should be constant, but when you're measuring rebound heights, it could get tricky. So the rebound ratio is going to be how high it bounces divided by how high it started, the drop height. So let's take the first one, 124 over 150. That comes out to about 0.83, right? 0.83. Let's just double check though. Let's do 59 over 70. And 59 over 70 comes out to 0.84. And then let's do one more just to see what, right? 100 over 120. That comes out to be 100 divided by 120, 0.83, right? So I would say the rebound ratio is approximately 0.83. That's for A. Okay, B says predict how high the ball will rebound if it's dropped from 275 centimeters. So let's do B here. So the drop height, right? The drop height is now 275, right? 275. And they want to predict the rebound height, so that's X. And we know the rebound ratio is 0.83, right? So it's X equals 0.83 times 275, right? So 0.83 times 275 is 228 and a quarter, but I mean we approximated on rebound ratio, so I would say that, it says round to a reasonable number of decimal places. I would say that no decimal places are reasonable since we rounded the 0.83 anyway. So I would say it's going to bounce to a height of 228 centimeters for B. Okay, let's make some space here. So C says suppose the ball is dropped and you notice that its rebound height is 60. So now they're giving us the height, right, of 60. And now they want to know where it was dropped from. And that is going to, again, equal 0.83. So I get, I could do it in two steps or one step, right? 60 equals 0.83 times X, if I multiply X by both sides, and then 60 divided by 0.83 equals X. So 60 divided by 0.83 comes out to be about 72. So for C, the original height was about 72 centimeters, right? Was about 72 centimeters. Okay, for D, suppose the ball is dropped from a window 200 meters up, D, right? It's dropped from 200 meters up, so that's the drop height. What would you predict the rebound height be after the first bounce, right? After the first bounce. So that's, again, the bounce height, and that's going to equal 0.83. So we get X equals 200 times 0.83. So 200 times 0.83 comes out to about 166, right? So 166 meters. That's what I would say it would bounce up to. And then it says for E, how high would the ball rebound after the second bounce? Okay, so after the second bounce. So let's clear C. I'm going to leave D since we need that answer, right? So for this one, after the second bounce, so in this case, this 166 becomes the original height, right? So 166, and we're looking for how high it's going to bounce this time. Again, the rebound ratio stays the same. So X equals 166 times 0.83, which comes out to 138 approximately, 138 meters. That's what I would predict it would bounce to.